Hello and welcome to this Codefresh live event. This is Automated Serverless Pipelines with GitOps on Codefresh. Our presenter today is Dan Van Brunt. He is the Senior Director of Technology at ClickHealth, where they've been doing a good amount of work on serverless over the past year. He's going to share with you what they've learned along the way and even share some of his advanced pipelines he's developed so you can replicate this workflow for yourself. So with that, I will hand this off to Dan to tell you a little bit more about himself and start the presentation.
Hey there, guys. Yeah, this is Dan here behind the mic. Hopefully everybody can hear me okay. If you can't, just chime in and Taryn will let me know. But just a little back history on myself. I am, as Taryn said, a Senior Director of Technology at ClickHealth. It is a full-service marketing agency. And I've been in the industry for about 15 years. I've been working with AWS for about 5 years. And we really only started getting into serverless architecture within the last year. I'm also an author at a Cloud Guru Medium publication where I write about serverless automation and the cloud. I have learned a lot in the last short little while, but I just want to stress I'm not an expert. So you may see things you may disagree with, so please provide feedback and that would be greatly appreciated. I am, or I should say Click has been a customer of Codefresh for, I think, a little over a year now, almost 2 years. And we're really happy so far with the support we've had through doing things that in containers as well as serverless. I just want to say you can reach me via email or Twitter, Medium, and GitHub via IDVB. And let's get started here. Okay, so we're going to start with what is serverless, and I like to start here just because I myself, when I first started getting into serverless, was pretty confused just with the term. And then when I started doing presentation to various different people around serverless, I found that they shared some of those same confusions around what it really is. So we're going to talk about that. We're going to get into the Serverless Framework, which is a CLI tool that helps deploy serverlessly. And so we'll dive into some of the things there of what that can do and that type of thing. And then I'm going to sort of frame a goal that we had as a company going serverless with some of our infrastructure and then some of the challenges that we faced immediately as soon as we did so. There's going to be a live demo where I'm going to show you basically a framework that we built or a platform that we built that allows us to do some really quick deployments of serverless infrastructure in a very sort of defined way with custom URLs and that type of thing. And that's part of one of the goals that we're talking about as well. We're going to dive into some of the code. There's a lot of it here because you'll see at the end I'm open sourcing and sort of giving out to you guys the platform that we built that helps us deploy really quickly, as well as some of the containers that we use with Codefresh. And so there's a lot to cover. What I'm going to try and do is just sort of touch point on a few things that I think are kind of important in understanding how it all fits together. And then during the Q&A session, if somebody wanted to sort of say, hey, could you just show this other piece, I'll try and do that. And then at the end, of course, we're going to have questions. Okay, so what is serverless? First of all, my first confusion with this is that it's actually a methodology, a company, and a CLI. So I found, well, and then aside from the fact that the wording is a little bit confusing. So serverless as a methodology is what we're talking about right now. And we're going to get into the CLI and the company after that. Here's what Martin Fowler says about serverless architecture. And I'm not going to go ahead and read the whole thing. But one thing I want to point out here is that he's not mentioning anywhere in there anything about that there isn't a server. There's still servers involved in serverless architecture. It's just the key point of serverless architecture, I think, is to say that managing those servers is not your concern. That's the concern of your cloud provider and the service that you're using to accomplish whatever the features are that you're looking for that piece of your architecture. So that's really the key thing is that it's not that there's not servers, it's just there's not servers that you care about per se and that you have to manage because they're managed for you. So an analogy I like to use is this. So this is a wireless charger. I think that's generally what we call this. But obviously, comically, there is a wire in the picture. So, you might sort of think of this or sort of attack the same term in this way where, why call it a wireless charger when there's a wire involved? Why call it serverless when there's a server involved? And I think the point is that us as users or clients of this service, which is to charge your phone, you only care about taking your phone and putting it down on that charger. That's all you have to do in order to charge your phone. You don't have to mess around with wires. So there is a wire back there. It's just not one that you have to care about on a day-to-day basis when you're charging your phone. So that's kind of an example that I like to give. I think part of the complication here is the word itself. So it says serverless. So if you say it that way, it sounds like there's no server. Another way that I've seen people really try to do it with marketing is to really enunciate that less at the end. So it's serverless, less servers. And then I've even heard people refer to this as service full, which is sort of to get away from this idea of that there's no servers. It's just more about there's more services at play that you're playing with, and you don't have to care about those servers. Okay, so serverless traits. A lot of times when we talk about serverless, in this presentation, we're going to sort of focus on AWS Lambda and AWS. But these ideas of serverless are cross-cloud, and there's a bunch of different things. But one of the things that they really share is some of the traits that we got out of when AWS Lambda was released. So it's this idea of that, it's promoting microservices, this microservice architecture, zero administration. So it handles auto scaling, monitoring. You don't have to worry about OS updates and security updates. It's pay per execute, which basically means you're paying for just the piece that you're executing, just for the time that you're executing. It's not an instance, a long running instance that you're paying for even when it's idle. It's event driven. So if you're using all these different services at play, it really comes in handy when the different services can interact with each other via this event system, this very powerful event system. And that's where this interoperable with other managed services comes into play. So one of the first things to take a peek at when we're thinking about serverless, just to sort of complete the picture in a single example of what serverless might look like, this is a very, very contrived, simple example of a serverless application. So you'd have, in the case of AWS, you have Route 53, whereas your DNS and your domain, and the user might come to your website, site.com. And when they come to that site, it's going to hit the CDN, which is CloudFront. And that CloudFront is going to be requesting the resources, potentially HTML, CSS, JS, that'll be sitting in an S3 bucket. Once that comes back to the browser and it loads up, potentially that JavaScript might make a call out to an API, which would be API Gateway as a service with AWS. And then depending on the method that you're trying to run in that RESTful API, it would fire different, or it could fire different lambdas behind the scenes. So you might have one for user create, one for user update, one for delete. And those may manipulate, as an example, a DynamoDB table. And now, if you look at this larger picture, every piece in this picture is, again, pay-per-use, pay-per-execute, and that type of thing. So you're essentially, if you deployed this and nobody came to your site, I think you pay 52 cents is what you pay, because there's a standard 50 cents a month for the CDN itself. But that's at least what we're seeing as an example for minimum payment. So that's pretty small to have this large infrastructure that could potentially be production ready and just sitting there waiting for you to use it. Oop. Okay, so that sounds great, but what's missing? So Lambda's been around since 2015, which is almost 4 years. And why isn't everybody just using serverless? We've heard a lot about it lately. We've heard a lot, obviously, about containers and that type of thing. But why is it that serverless isn't just something that everybody uses if it's free when it's idle and that type of thing? And I think some of the reasons are because of the fact that at the time, or it's only 4 years ago, that a lot of the CLI tools just weren't mature enough, and a lot of the tasks that you had to do in order to manage serverless was very monotonous and time consuming. And since then, they've developed some really great tools, so that sort of point is less, I guess, apparent today. One of the other ones that is still sort of there is vendor lock-in. So the idea that if you set up a serverless infrastructure with AWS and you're using all AWS services, they're very proprietary in the calls that they make to each other in the event system. And so how do you move to another vendor if you wanted to do that? Again, I won't get into it now, but there is things coming that even potentially hint at being able to work around those challenges as well. So the first that we're going to talk about is the Serverless Framework, which is a CLI tool that allows you to deploy those serverless resources to AWS, as well as a number of other cloud providers. The Serverless Framework was originally created by Austin Collins. Shortly thereafter, I think they formed a company which is fortunately or unfortunately called Serverless, which is where some of the confusion, at least for myself, led to. And so now they're developing all sorts of other things in conjunction with the Serverless Framework CLI as well. So the CLI supports a number of different cloud providers, but it supports at least the main four ones, which is AWS, Azure, GCP, and OpenWhisk. But you can see there's a couple other ones down below that it also supports. Again, for this presentation, I'm more familiar with using it to deploy AWS. So one thing to keep in mind about what it's really doing under the covers when deploying with the serverless framework is it's going to boil down, you write it in YAML, and you write your configurations in YAML, and at the end of the day, it's going to boil down those into a AWS CloudFormation template, and it's going to deploy that and use CloudFormation to deploy your resources for you. So it's very predictable in that you know that it's always going to end up being as a CloudFormation template. It's also very versatile because it allows you to define things the way you would normally do it if you were just natively using CloudFormation, but it allows for a ton of extensibility and a ton of making certain tasks that you would normally take a lot of time to do, manually writing all the different Lambda functions for all the different RESTful APIs and things like that. There's a bunch of things that helpers that allow for quicker writing and deploying of those functions. It obviously, if at the end of the day it's using CloudFormation, you do have access to a number of other services, but primarily the services that the framework, the CLI, allows you to use really quickly is Lambda and API Gateway. As well as IAM. Okay, so just framing the goal of sort of how we started and what we needed for our team and with serverless and some of the challenges that we got into. We wanted a 100% automated pipeline. So we wanted to be able to write unit tests, integration tests, security tests, perf tests, code linting, and we wanted Slack notifications. And we wanted 100% automated. That meant zero to hero, dev to prod. So we wanted to be able to have it so that when you commit to a feature branch, that it's going to generate you an environment that is for that feature branch, and that somebody could, send to a project manager or a QA person, and they can do some testing on that. And then that code could be merged into dev, and then later merged into maybe an RC branch or production. And sorry, when I say merged into GitHub, those different branches, and the sheer act of merging, let's say from RC to master, would automate deployment of that environment. So that's what we were looking for, is that fully automated piece. It had to be 100% GitOps, so it had to be integrated with GitHub and using all the different checks and balances that GitHub allows developers to do in terms of moderating what gets merged into which branch. And of course, we wanted an infinite number of dynamically deployed environments. So as I said, when we deploy feature tree, we want to have a tree environment. When we deploy QA, we want to have a QA environment. We wanted all these different environments to be able to spin up so that we could do those testing on that feature the same way that we're very sort of accustomed to in the container environment. This is something that we can do locally on our machine really fast, and if you're using Kubernetes and that type of thing, it's fairly quick to deploy those things. The challenge is how to do that with serverless. The other thing we wanted is a predictable URL. So in the case of, we're using, at least for this demo, clickstuff.com. And so the idea would be, it would be the branch you're working on, dash, the service, or like, let's say the project you're working on, and then .clickstuff.com. So anytime a new feature was created and somebody wanted to test it, they would have a predictable URL they could go to see that environment. So the example below is feat-thing -- project X being the project .clickstuff.com. And many of these environments that we're deploying are a lot more complex than the simplistic example that we showed above. So this is a shot of one of the more complex, well, the most complex application that we've built serverlessly. It's a media streaming platform similar to TED Talk type of thing. And it has an auth system, a front end, a transcoder, a GraphQL API. It has an AWS Elasticsearch, DynamoDB, on and on and on. There's a ton of pieces to this thing. And so we needed multiple stacks and they all had to be deployed. And so this type of a thing also needed to be able to live within that same pipeline and that same workflow. And here's the gotcha. Things had to be very fast. So we're talking, we wanted things to be running, you know, on average around definitely under 5 minutes. Closer to 5 minutes felt very, like, way too long for us to wait, especially if you want to have a quick feedback loop with your developers' changes. And so we were almost there. We deployed this a number of different ways. We tried a number of different takes on how to get these environments up. And one thing that we found is there was the bottleneck for time always came down to the largest one, which was the CloudFront replication or deployment times, which are 30 minutes. So when you're trying to pack everything down to a 5 minute or less deployment time, and there's a piece in there that takes 30 minutes, it's, in our eyes, was just like unusable. We couldn't deal with that. We needed something faster. And so, and the problem here is that CloudFront is really sort of a keystone in a lot of the different infrastructure that you would potentially be deploying. And there's ways around it, and there's ways to, depending on the infrastructure that you're deploying, you may not even need CloudFront if you're using an API. If you're building an API, RESTful API, and that's it, those domains get generated for you, so you don't need to deal with the full 30-minute deployment times. Where this really came into play is when we wanted those predictable URLs, those custom URLs, and that type of thing. Certainly, we could have employed a number of other things in front here that are not serverless. So we could have deployed, containerized environment that could handle some proxying and routing. We could have used application load balancers, things like that, that handle those routing. But in many of those cases, at the end of the day, there's still some idle time that you're going to end up having to pay for, at least from the services that we had used up to this point. So we wanted to find a native serverless way to do what we're looking at here. Okay, so what this basically boiled down for us is trying things a bunch of different ways, and we figured that maybe there's a way that we can build a little sort of mini platform. It's pretty small, and all it's really going to do is handle routing that's going to come into a CloudFront CDN. And the idea is that we don't want to, in this case, we don't want to redeploy the CDN for every single feature branch or for every single project. We're going to deploy ahead of time the serverless infrastructure that'll handle that dynamic routing as projects come on and offline. And because we don't have to redeploy that one CloudFront instance, it allows us to have those custom URLs without having to wait those 30 minutes. So really, at the end of the day, you're only having to pay for the deployment times. You really only have to pay the time for, I shouldn't say pay, you don't have to wait the times for the CDN and the custom URLs to deploy. You're really just waiting for the rest of your infrastructure to deploy. So in order to accomplish this, we used with Codefresh, we built our own build harness container that has Node.js and Yarn, the AWS CLI, and Serverless Framework CLI installed in it. We built a thing that I'm just for now going to say is a proxy stack. not really even sure if the naming is great on that, but it's what we internally called it. I have a diagram next where it's going to kind of hopefully paint a little bit clearer of a picture of what this looks like. But the proxy stack is basically a static CDN that sits there, a DynamoDB table, and Lambda at the edge. For those of you not familiar with Lambda at the edge, it's basically running Lambda functions right on your CDN and close to the user that is making the call. We also build a custom resource. It's a CloudFormation custom resource, which presents itself, when you use it, it presents itself like any other AWS resource, only behind the scenes, it's firing calls to your custom Lambda. And so our custom Lambda is basically doing nothing more than updating a matrix, sort of like a field entry in the DynamoDB table that says, hey, if somebody comes to feature blue subdomain, then route it to the S3 bucket for that project, kind of a thing. That's how we're able to handle routing. And this could even be rerouting to EC2 instances. It doesn't necessarily have to be buckets, but at that point, obviously, it's not serverless. The last one is the demo project itself, which is just the project, whatever project in question that you're trying to deploy and to have environments for. So for this presentation, I've put together a demo project, a demo site that we can look at and take a look at how it uses that custom resource to declare which stack entry it wants to be for that deployment. Okay, so this is basically what I've been talking about over the last little while. And if you look at the bottom, there in the center is the CloudFront CDN. So that stays there, that's deployed ahead of time, regardless of any projects that are live or not. And then behind it is or right against it is the Lambda at the edge, which is basically the decision maker on which way to route to the proper origin. Origin being essentially the destination that it's going to be routing to get the resources in question. So the example is somebody comes into the site looking for feat blue -- project X, and it's going to go to the Lambda at the edge. The Lambda at the edge is going to detect what the subdomain from the request is, and then it's going to do a lookup from the DynamoDB table, and it's going to find that that's the blue bucket because you asked for feature blue, and then it's going to route to the blue bucket. And all of this is sort of seamless to the user. It just happens. You don't see anything in your URL bar or anything. It just forwards you onto the proper origin and the proper resources. The only other thing to mention is that you could also have a bunch of AWS API gateway stuff behind the scenes, and you could choose to even have that routed by the Lambda at the edge so that you get custom resources. So you get a custom URL even for your API, so that you could have feature blue .projectx.com .clickstuff.com/API. Like, you could do that as well. We haven't done that just yet, but I mean, you definitely could do that. This just allows it to sort of sit on its own and be deployed on its own if you want. And then at the very top is where it shows a little black and white block, is saying that's where in that blue bucket project that has an API and a bucket defined in it is where you would also define and use the custom resource that tells the DynamoDB table to add an extra row that defines that mapping between the feature branch that you're trying to get to and the origin that it should go to. It's a little bit hard to sort of hold up in your head, but it'll probably, hopefully, make a little bit more sense when we dive into the demo, and that's where we are. So I'm just gonna bust out of the presentation here for a moment, and I'm just gonna sort of give us our bearings here. So I've got in one of the windows our Codefresh pipeline, which is for demo site, which is gonna be this demo site that we're gonna show. I've opened up CloudFormation in AWS just so that we can take a look at what are the stacks that we have built right now. So for those that aren't familiar, CloudFormation is basically a service that allows you to define things in YAML or JSON in various different services across AWS, and then they get deployed to CloudFormation as what's called a stack. And so the stack, the singular stack itself, would define and hold true any of the declarations excuse me, any of the declarations that you made internally for the resources that would be under that stack. So the stacks you can see here, I've already pre-deployed a sort of dev version of demo site. I have the stack proxy itself, which is the thing that that's going to enable us to have those custom URLs. And then just below it is the stack for the custom resource that allows for entries to be entered into that stack proxies DynamoDB table. So next up, I just want to show you the DynamoDB table right now. If I hit refresh on it, the only entry I have is dev, which we saw was deployed as a stack. And it's saying that that's the host that's going to be coming in. And the origin that we want to pass it to is this specific bucket behind the scenes, which represents the dev version of that demo site. These are just the resources, or sorry, the repos aligned with those various different services that we just talked about. And then lastly, this is what the site, the demo site looks like when deployed. So I output to the front end here the stack name, which is a unique identifier, which gives us the project in question, which is demo site. And then the last piece is essentially the branch or the stage or the environment that we're talking about, which is the dev version of this. And then I've also sort of put up on the screen the service endpoint. So I guess this is where I would say what I'm showing you on deploying this demo site is really handy because you can see sort of how all the different pieces fit together. It's not so great because it sort of looks like I'm saying that you should deploy your front end and your API at the same time, which is probably not the best way to do it in a production environment. You should probably break those off into two separate stacks and handle those deployments separately. But in the case right now that we're going to deploy them at the same time, the front end needs to know what the URL is of the API that you're deploying. So if you think about it in like an order of events, is the infrastructure needs to be created for the API in order to get the URL, and then you need to pass that URL into the code, the JavaScript that's getting built for the front end. In this case, it's React. And then that front end code needs to be uploaded to the S3 bucket that was also created as part of that infrastructure. And at that point, now when you come to the site will be able to get and hit that API endpoint. So in the case of this API endpoint, we're not doing anything fancy. I've just hard-coded inside of that API endpoint a JSON response that responds with a number of images. So in this case, 4 different images. And then the front end is basically when it gets those images back as a JSON object, it's just sort of iterating through them and displaying them on the screen as images. So this is basically the demo site that we're gonna just do a quick test with. I'm just gonna switch over to the code, and in this window, I've got the demo site open, and I also have the other stack proxy and the stack entry custom resource code, but I'll keep that collapsed right now, try and keep things a little less confusing. Inside of the demo site is the Codefresh YAML file, which defines the pipeline, which I'll definitely take you through and take a peek at. And then there's the serverless YAML file, which we're gonna also during the code review take a deeper look at. But what I want to just do right now is I want to sort of create a change. So I'm going to do nothing but just sort of put a space in here in the README. And then I'm going to commit that to a feature branch. So imagine we're going to create a brand new branch that we're going to call feature blue. And then we have that change that we put in, which is the README. I would not do your commit messages like this, but for the sake of the presentation, I'm just going to do it that way. And then I'm just going to push this up into Git. So right now we're creating a feature branch. We've done nothing but make a small modification to the README. And then if we go back to Codefresh, you can see that it's instantly kicked off a build for the branch feature blue for the demo site project, and it's currently in progress. We can also see that the Git short is ending in 1C0, which if we try to remember that, I'll show you something else that's pretty interesting when you're trying to track which versions you've pushed live. especially when it comes to a front end. And so if we come in here and just sort of take a look a high level at what Codefresh is doing, it's pulling down the main repository for this project and cloning it. And then we have it running some hypothetical unit tests. Right now, at least in this code example, we're not actually running any tests, but you could definitely be running any sort of unit test there or using any test tool you want. The next one is deploying dev. And so I'm going to pop this up open right now just so we can take a look at what exactly it's doing. Codefresh matched on the fact that I said I wanted this to happen for anything feat dash, as well as anything that's dev branch. And then it's just going to consider that as a dev type of a deployment. It's using our build harness down here. And right down here is where it's starting to provision the resources in AWS. So again, it's as part of this project, it's creating an S3 bucket, API gateway, Lambda, there's policies, IAM roles, there's a bunch of different things that are creating, as well as that custom resource, which needs to reach out and tell our proxy stack that it needs to add an entry in it. So all of this is happening right now. The important thing to point out here is one thing that we really like about this is that it's much closer to production-like. So, the closer you can get to testing in a production-like environment, the better, because then you're sort of shifting left and not waiting to the last minute to test another sort of different iteration or change that you may need to deploy this thing. And so this is great because literally what we're deploying here is all the exact production ready infrastructure. In this case, as an example, not the best example because you wouldn't deploy an API with the front end, but in this case, it's deploying the whole API and the front end as well. So again, fully automated. So this process usually takes less than 4 minutes, but let's see here. So we're about 3 minutes right now. So while that's doing that, I'm just going to pop over and show you the DynamoDB table and hit refresh. You can see in here it's added the feat blue the subdomain on clickstuff.com, and then forwarded it to a totally different bucket that was created as part of this change, which we didn't make a change to the actual code, but it could have very well contained the change that you wanted to make. The demo gods are not with us. This usually doesn't actually even take this long. Still within 5 minutes at least. I guess I can come over to CloudFormation here, and if we hit refresh as well, you can see that the demo site is being deployed here as a stack, and it says update in progress. So we could probably go into the events here and see what's the holdup. Okay, well, why don't we, I'm going to pop into the code and just show you some of the code while we're waiting for that. And if it doesn't seem to build, I apologize. There is a number of things that we had to put in place to make sure that for the demo, we have this available for you guys to look at. So we're hosting this on a different cloned environment kind of a thing. So there may be an issue. There wasn't previously, but. Okay, so if we look at the demo site right now and we take a look at, let's just quickly look at Codefresh. One of the things that I want to point out here is the deploy step. So in the deploy step, we're using that build harness, and we're defining which region to deploy to for AWS, and we're passing in the credentials for the environment we want to deploy to. So we have a production environment and a sandbox environment. And so in the case of a dev piece, we're going to deploy to that sandbox environment. So that's what is going to make that happen. And then down in the commands, there's an SLS deploy. And this SLS is basically an alias for the serverless framework CLI. Oh, okay. So just brief thing here is it let us know that our environment is now up and running. So I'm just going to click on that, and you can see inside of our Slack. So this is Slack here, and it's basically told us that Codefresh is deployed. There's my commit message if I wanted it. It shows you who did the commit. We can see the URL that the environment is linking to. We have a stack name, which is demo site feet blue, and shows the branch is feet blue. And then something I'll show you when we go back to the code is we also run a lighthouse test, which is around sort of front end performance in the browser. And it's given us a score of 63, which is not awesome. And that's because we don't have PWA for the actual app right now. We're not using service workers and things like that. But it's really handy because you do have that score. So every time we are making a change, we can sort of keep ourselves honest in knowing that that change hasn't blown up that performance score. So just diving back into Codefresh here, the YAML, that's where it's being deployed, and we're deploying it as whatever branch that was created. And again, in terms of when, branch only at the bottom here, we're saying only for dev and only for the feature branch. Towards the bottom here is the lighthouse test. And in the lighthouse test is where we are running the test using a lighthouse CLI Docker image, which is also provided in the notes at the end. And it's going to run headless Chrome to run those and generate a report. And then we're just basically going into that report and slurping out the overall score and using that, outputting that into the front end, as well as storing it as a Codefresh variable. And at the last piece is the Slack notification, which is basically going to generate this nice Slack notification that has a clickable link and the lighthouse test. And if we were to click that link, I'm going to just open this up in this browser here. So if we open that up, there is the site, but this is the one that is changed. So I can do that even, I don't know why I closed it, but I can come back here and I can go to the dev version because we haven't torn that down. And you can see that as far as the API is concerned, it starts in JZM. And if we go to ours, it's FJD. So it's even using a different API, RESTful API that's being generated. So again, that whole thing was deployed in, let's see if I was honest here, 5 minutes, so 6 minutes, just around 6 minutes. And that's not, I don't know exactly what happened there, but that's definitely not what we're seeing on average. In fact, if you look back through all these other deploys, most of them are taking, around 2 minutes or 1 minute. So it sometimes varies, but most of the time it's taking around that 5 minutes. I guess the other thing to point out here is this was the initial deploy. So this is what created the environment initially. But now that that environment is created, we could go back to the code and make changes to it and then deploy those. And those would probably take even, closer to that 1 minute mark, because it's not having to recreate that environment anymore. It's just making modifications to it. So it's much faster. The last piece that I want to show is what you can do when you are sort of completing the picture, because this is great. This environment is there and we can share that and it's posting to Slack and all that stuff. But as part of a regular dev workflow, I want to be able to come in here and I want to be able to say, okay, this is ready to go to, in this case, master and production, but that's not, that's not what you would do. Hopefully that's not what you would do in actual fact. You'd probably push this to a dev branch or that type of thing. But what I would do is if this was the master was the dev branch, well, we do have a dev branch. Let's just push to the dev branch. So what you'd normally do is you'd say, okay, I want to merge this feature branch into the dev branch. I've done all my tests and on the environment that was created, and I think it's ready to go. And I'm going to submit this as a pull request. Normally there would be checks and balances in here where you can make sure that everything's running from a Codefresh point of view. There wasn't any build errors. You can add other checks. We add checks for dependency sniffing using Sneak and that type of thing. So you can make sure that there's no vulnerabilities in any of the dependencies you're using. All of these things can happen right here. And then everybody else can basically, you could basically say, well, if you want to push to dev, you only need one person to approve. But let's say if you needed to push to master, you might need 2 or more people to approve. But the end result is you would say, I want to merge this into dev. And once it's approved, the approver would then go ahead and delete the branch, which is great because the branch it's not needed anymore. We've already merged it into dev. But the question is like, well, what happens about that stack then? Because that stack's not needed anymore, that environment, right? Well, if you use this proxy stack that we've built, it actually uses a GitHub webhook that will notify a Lambda, letting it know that that feature branch was deleted, and it will basically sniff down exactly which environment in CloudFormation that represents. And in this case, it represented that feature blue environment, which is now removed. Also, you can see that because we've merged into the dev branch from that feature branch, it's now just making sure that that change is being deployed into that branch as well, which is probably a good example if we come back to this window and we can see dev is still in progress. This is probably more indicative of the deployment times that you get on average once you've actually deployed once, because in this case, that's all it's doing is deploying. So you can see it's already deployed to dev, and it jumped past RC and prod, and now it's just running that Lighthouse test. And the beauty is that Lighthouse test is actually making the requests from inside the container and on Codefresh, but it's hitting our public. Sorry, I shouldn't say public, our deployed environment. And there's a number of things that you can do to protect that communication between that deployed environment, especially if it's only a development environment. There's trust that you can build between your container and Codefresh's environment and your environment. And there's things you can do with IP whitelisting and that type of thing. So there's a number of different options there, but that's generally how that works. And if we go to the build, we can say, okay, yeah, so it took around 1.5 minutes to deploy a change that affected the front end. One last thing I just want to show is if we go to the build, the feature blue build that we built here, you remember where I'd sort of called attention to the fact that it's 9F4 here, that 9F4 being the commit hash. And if I go to my front end, which is this feature blue, you can do an inspect here. And if I go up to the HTML node, you can see there's 9F4. So we know that like, hey, this front end that I'm looking at is the right version for what was deployed for that, which is, again, this is something that's really relatively easy to do and trust when you're working with containers. And it's a little bit more effort when you're looking at doing things serverlessly to fully understand all the different resources and what versions all of those could potentially be in. So we found that that helps. And so I just have I think just under 1 minute now before we potentially jump into questions. Is that right, Taryn?
Yes, but take your time.
Okay.
I just see about 3 questions we have. So if you want to go on, please.
Okay, sure. So I'm gonna just sort of show some of this, some of the code here, and then we can jump into questions. One of the things I wanted to show was in the serverless YAML. So I apologize, this isn't gonna be, I can't necessarily dive into fully explaining how the serverless framework works or CloudFormation templates work and that type of thing. So this is gonna be a very cursory sort of look at this. But if you had any other questions, please reach out to me. And I can definitely provide you with some answers as well as some links to learn about some of these things more. But if we look at the serverless YAML file, right at the top, it says service, and we're defining it as demo site. So everything below is sort of going to cascade off of this one name. And when you do a deploy, we saw in the Codefresh file, we're saying SLS deploy -s, and then we're providing it with the branch name. So in the case of feet-blue, that was the name of the branch, feet-blue. And this is deploying to the stage or environment, in the case of serverless framework, called feet-blue. So in the case of this service, it's going to end up with a stack named demo-site -feet-blue. Would be the fully qualified service name once that version, that stage version of it is deployed. You define what framework version in terms of the serverless framework that you're saying that this works with. There's a custom section, which I'll get into, which is basically defining custom variables that you can use throughout your template. There's a provider section, and in this you define which cloud provider you're working with, in this case AWS. You can provide the region. You can also provide the runtime for the Lambdas that may be deployed. So in this case, it's using Node.js 8.1. And then there's just this idea of that all different resources can be tagged, which is really helpful for billing. And so you could do this stack tags thing, and you can define your own tags. So in our case, we wanted to sort of define that actual resource, which stage was that? So it was feet-blue, and which service was that? So that was demo site. And then that would allow us to filter using those when we want to look at where our billing is coming from and that type of thing. If we look at the functions section, this is basically where you would define your functions. So we're just defining one function right now, which is get images. And get images is going to go out, hit that Lambda, get the JSON response of the various different images, and then come back to the front end. You can define a number of things in here, memory size, timeouts. But the key here is you're defining what event is going to trigger that Lambda function. And so in this case, the event we're triggering it with is an HTTP event, which is basically API gateway. So just by you saying, I want an event that's HTTP, when it deploys this, it's going to create you an API gateway endpoint, and it's going to create the Lambda, which is get images, and it knows where to find the actual function code because we've defined that here in the handler. And then you can define a path on that endpoint that will be fired. So in this case, I'm saying images. You can define what method, and you can define whether you want to support CORS or not. Lastly is how to package it up. I won't go too into detail there, but that basically tells how to package the zip file for when it's uploaded to the Lambda in AWS. The last piece that is the most important, well, the last two pieces are the resources section and this output section. The resources section, I like to think of anything under the lowercase resources section. So basically description, conditions, resource, and there's a number of other things you can specify here. This is nothing more than native CloudFormation template, which you don't need to use if your thing you're trying to build doesn't need that. But this is literally, you can define anything you can define in a CloudFormation template, you can define here. And so the piece that I want to show you is this proxy entry. So in this proxy entry, we're defining, that's our custom resource. So we're saying use this custom resource, only do this when you're deploying to the dev environment, which is a condition, which again, I won't really get into, but you can set up these custom conditions that you can use to define whether you should or shouldn't be deploying a resource. And so in this case, this is only going to do it for a dev resource. And then our actual service that is going to handle that custom resource, adding that entry to the DynamoDB table is basically already created out there, and it has a exposed variable that you can sort of use to reference it, so that on all of your projects you could say, hey, use that exact custom resource. So I'm saying use the demo stack entry custom resource and the dev version. And what that's going to do is that's when this resource gets created, it's going to use that specific Lambda to do the creation. And I'm passing in the domain that I want to use. which is referenced via those custom variables that I sort of skimmed through at the top, and then the origin that you want to send it to. And again, I can't get really too deep into the CloudFormation template structure, but this is just native CloudFormation templating that tells it, I want you to inject the domain name of the website bucket, which is defined here, which is the S3 bucket that all of these variables, all of these resources are going to, sit in. So all of that ends up getting created, and it uses stack outputs, which are these right here that define any number of things. I could create any number of these that I want, and I could put static variables in there, strings, or I could import different properties of different resources and things like that. So it's just outputs that allow you to sort of say, when this stack gets created, once it's live, I want these outputs to be there so that somebody could read them and potentially use them to link to them. So in the case of like an API endpoint, you might launch that as a separate stack, and then you have your project that needs the endpoint. So when you launch it as a separate stack, you'd have that as one of the outputs, which is the endpoint that your other stack could then import and use. In this case, we're just doing it in a single one. But these outputs come in handy because in there is our service endpoint, which is our API endpoint that gets defined. And using a plugin, a serverless framework plugin that is output, it's going to output a .env file, which is just an environment variables file. And it's going to dump the variables from here, these output variables, into that env, so that the very next step when we build the front end code, it's going to sort of bake in those endpoints, like the API endpoint that it needs to reach out to, it'll bake it into that file. So that's kind of all of the sort of end-to-end view of how this serverless framework works in conjunction with Codefresh, and how you can deploy things pretty fast using this proxy stack that we're working with right now. I think at that point, I'm covering a lot of stuff. There's a lot there. So I apologize, but I just want to give an opportunity now to open it up to any questions that may have popped up, and we can take a look at any specifics.
Great, thank you so much, Dan. And if you'll head back to the presentation for us, I just want to make sure that everyone can see how to contact you and our thank you page. And I also want to introduce, we have Dan Garfield on the line, and he is our Chief Technology Evangelist and also a full stack engineer at Codefresh. So he'll be helping to address some of the questions as well.
Yeah, so I'm just going to jump in really quick and say, in this PowerPoint presentation is those code examples that I forgot to pull up there. So we'll make sure we provide those to you if you need them.
And I think Taryn mentioned it would be posted on the blog as well. Right. So let's jump right into some of the questions that we had. Greg asked, with the heavy use of Lambda, do you find operational costs have gone up or down versus using EC2 or something like that?
Yeah, so that one is I think I've at least been my experience is that one's really hard to get a definitive answer for, and it's really the one that everybody wants to know, right? Because if the definitive answer is yes, moving away from EC2 and going to Lambdas, you're definitely for sure, no matter what you do, going to be cheaper. Then obviously it's worth the time to switch. But at least in our experience, for sure, like the types of infrastructure that we've been deploying is like zero costs. We went, some of our I mean, I won't get into dollar values here, but some of the environments that we were deploying before on EC2 instances and even RDS databases and things like that didn't necessarily need to be that way. So for those of you that might not be familiar with DynamoDB, there is definite use cases for using it, and there's other ones that it's not really the greatest use case for. In our case, it was definitely more than enough. And so when we switch from RDS databases and switch from EC2 instances that host our front end and potentially our APIs over to using Lambdas, I mean, we're seeing drastic changes in what we're, like reductions in what we're paying for. And then also the fact that whenever we had those other environments, you needed multiple environments. So you needed to have your production environment, you needed to have potentially a stage environment, because you didn't want to have to wait for that EC2, those instances to boot up every single time that you wanted to test a different feature branch. So they kind of sat there statically, and they were always available whenever you wanted to push changes to them. And so your costs would kind of stack up. But with serverless, I mean, we can push thousands of environments that nobody's really going to care about later, other than for a couple of tests and showing QA. And we could literally leave them sitting there and not doing anything with them, and we're still not really paying much more than that minimum. That minimum I said, which was like 52 cents for CloudFront. And in the case of our dev environment, we only have one CDN because it's that proxy stack. So even then, we're only paying that one instance of it. So, I mean, yeah, for sure. It definitely depends on your use case, though, for sure. I think you're mute, Dan.
Thanks. So I think that was a great answer. I think it's a little bit different than something like Kubernetes is sort of like a general, like, hey, we're going to do everything Kubernetes. And it's like, okay. And like maybe you're doing serverless on Kubernetes too, and that's fine. With Lambda, it does sound like you need to be just a little bit more selective about the kinds of workloads you decide to put on there. Running all your video transcodes or something on Lambda might have cost problems, right?
Yeah, I mean, I just want to just sort of comment to that too. That is one thing that happens, I think, invariably whenever you sort of look at serverless and you start investigating it. You'll sort of say things like, because Lambda, as an example, can only run for 5 minutes, you instantly say, well, that's not going to work in all these different cases that I know that I need to run something for longer than 5 minutes. But I think the best way to look at that when you're thinking of serverless is not to sort of point out the flaw in the one service, but more so ask yourself, what is it that I'm trying to do? What is the feature that I need, which is like long running processes for, you know, maybe analyzing data or that type of thing. And then ask yourself, with the cloud provider that I'm working with, is there a service for that? If there's a service for that, then you don't use Lambda. You maybe use Lambda to trigger or that type of thing. But at the end of the day, the service that's doing the long running process is another serverless service that may be provided by your cloud provider or not. But that's where those decisions can be made. So it's not necessarily that just because, like, Lambda isn't the only serverless service out there to perform a number of different tasks for you. So certainly if you're trying to do a specific type of task, like you say, transcoding, you would use AWS Transcoder, which we actually use in that example that I showed for the media streaming platform that's 100% serverless. We're doing transcoding a video that takes, you know, hours potentially, and it's serverless because you're using a service that was built for doing that long running process.
Great, thank you. Now, Justin asks, are there reasons to write the pipeline as a single pipeline versus creating multiple pipelines, each corresponding to a different environment?
I guess I'm not sure if the question specifically referencing our proxy stack as sort of that pipeline, or if we're talking about Codefresh's pipeline. Because I'll try to answer it a number of different ways. If you're talking about the Codefresh pipeline, we are right now having one pipeline per se per repo. So I'm pretty sure, I mean, Dan, you could correct me, but I'm pretty sure you can have a number of different repos triggering off of a single pipeline so that you sort of keep things like, we want this pipeline this way, and no matter what repo is triggering, it's going to go down that pipeline. Certainly you can do that, and I wouldn't doubt that may end up being where we go. It's just right now we're creating a single Codefresh pipeline per repo right now.
Yeah, and to follow up on that, Justin's, I think, is specifically asking about seeing dev, release candidate, and prod in a single pipeline.
Yeah, and I'm definitely, you know, I think I would basically sort of refer to what I said earlier as I'm not an expert. So I'm definitely interested in, you know, other ways of doing things, because yeah, it probably makes sense in some cases to have different physical pipelines to handle those different environments. For sure. It's just,
yeah, the use case that comes to mind for me is what we see lots of times, actually larger companies enterprise companies is they want to have a totally pipeline for production that maybe has some special properties about how it's accessed, just for security reasons, to control the release process a little bit more stringently.
Absolutely. Yeah,
That's
a
the
really,
main reason,
really
I
good
think. But even in that case, it could use basically the same pipeline, but have different values loaded into it or something. It could use sort of
Sure.
a pipeline. So anyway,
Yeah, 'cause I guess there's many different iterations of that. You could have it so that it's loading in the same YAML, but it's using a different pipeline, or it's different YAML files. Yeah, for sure.
well, you can get real funky, and you can actually have a pipeline of pipelines. So you can componentize pipelines, and then
pipeline inception.
so you get a little crazy with it if you want, but yeah, security comes to mind, and maybe like just the reproducibility. Using a single pipeline is nice because then your project conforms to that. It becomes a de facto standard, which I think there's actually a lot of value in an organization. Justin asks, is there a way to add manual judgments to a pipeline? For example, if a team wants to inspect test results before going to prod.
I am not familiar with that, but do you know, Dan? I think you could.
There are a couple of ways to handle this. One is actually just through your Git flow, right? Because you could review a pull request that actually is all of the test results that you're inspecting, and once approved, it merges and then deploys to production. Another example of how people would sometimes do it is you can also create. There's custom webhooks on pipelines, and so sometimes people will actually have a step that sends a message to Slack that says, this appears to be ready, click here to deploy it, and what it does, it actually triggers the final step to actually deploy from its pipeline. So there are some ways to do that that require just a little bit of creativity, I guess. But
yeah, I guess I can add to it too. Is just I wasn't, I guess, 100% sure on the question, but now I fully get it. So as you mentioned, Dan, one of the other things you can do is have those checks and balances as part of the pull request. And so in GitHub, as part of your flow, you can have a number of different checks that are happening. So maybe you're not pausing a specific build itself. It's not getting, it's not starting to run down that pipeline and then stopping and pausing, but ahead of time when you've built that thing and sort of said with a PR request that you want to push this into a specific branch at that moment, it can run through those different checks and balances. So a couple of the ones that we do is that lighthouse test. So we could do lighthouse tests as part of a GitHub hook as well. And you could also do another one, which we do, which is using Sneak that will give you some information on those dependencies. So if all of a sudden it found a vulnerability in one of your dependencies, you could literally prevent it from deploying or being merged into master. So those are some things that we've done with it.
Yeah, and I think my best practice recommendation is to use GitHub as the final place to do the manual trigger, but that's some that comes down to preference. Roshan asks, are you using AWS CLI to execute the CFN? Debugging in this case can only be done on CFN console window, right? How do we locate issues in Lambda and serverless code?
So I guess the piece I could say is underlining to the serverless framework, it's using the API, AWS CLI. So you still have, I mean, it's still under the covers, still using AWS CLI. I don't know if that helps answer part of it. As far as debugging,
you mean the serverless framework is using the AWS CLI?
Yes, yeah. Under the hood, it's basically using the AWS CLI, or at least it's using the API, the AWS SDK to deploy the CloudFormation scripts and that type of thing. But I guess this is a good point to say that part of the reason why we wanted to use Codefresh for doing this is because of it has its sort of like bring your own container style and pipeline. allows us to bake in all of those things that we may want to do with the AWS CLI, or if we want to do template checks to make sure that there's no errors in the template, which is actually something that the serverless framework does. It makes sure that at least your template itself is not going to fail or something's going wrong. So you do get those errors if you try to deploy something and it's not going to deploy from an infrastructure perspective. It's not going to deploy, or there's going to be some issues. So those things will come out using the CLI. The piece that I think you're mentioning that I'm not 100% sure on is sort of like, how do we locate issues with the Lambda code itself? And that's the piece where you could write unit tests that could unit test that code, and you could absolutely do that as part of the Codefresh pipeline. You could there's a number of linting tests you could do. You could do integration tests, so that if there's a bunch of different things you want to check to fire at that function after the fact that it's deployed, you could do that. There's a number of things you could do, but yeah, I'm not exactly sure if that answers directly the question, because it sounds like you're looking for something that, as part of the CLI itself, you were looking maybe for something.
Well, I think that answers it.
Okay.
I think that answers it. So with that, I think that was incredibly informative, and we were very lucky to have you, Dan, to come and do this. And for those that don't know, you've been using Codefresh for almost 2 years now, your team.
Yeah.
So your team are veterans, and very exciting. This all came about because we ran into each other at DockerCon, and you were telling me about the stuff you were doing, and I said, serverless is really exciting. We'd love to showcase the right way to do it. And thank you so much for coming and sharing this, and putting together those project files, getting the GitHub together, and putting together the slides, which is going to make it so that all the people who listen to this can go and replicate what you've done in a lot less time than I'm sure it took you to get set up initially.
Sure.
So
yeah,
with that,
the only other thing that I would just mention here, this is my shameless plug, I put it in here, but I forgot to mention it, is I also have a course that I've released with the Cloud Guru that it goes through deep dives into how to work with Lambda at the edge, which is used in this example. So if any of you are interested, then head over to Cloud Guru and check out the course.
Perfect.
Thanks again, everybody.
And as the final note, once you get this replay, if you found it useful, please share it, put it on Twitter, put it on Facebook, email it to the rest of your company. Really helps us know that we've built the right kind of content, and encourages us to get more of this kind of content. So it's a great way for us to know that we've hit the right thing. So with that, we're gonna come to a close. So thank you very much, everybody.
Thanks, everybody.